about inequalities. So first off, you should see the word equal in here, and you should see in, which means not equal. So inequalities are used for numbers that are not equal to each other. So when you were in elementary school, you saw things like -2 is less than 0, and 4 is greater than 3. So let's remember these symbols. So we've got less than, and we've got greater than. And you read these left to right, just like we read English. So -2 is less than 0, 4 is greater than 3. Now, you could have something like -2 is less than or equal to -2, because when it has this little line underneath, that means less than or equal. And by the same token, you can have that for greater than. So it could have 4 is greater than or equal to 4, and that is still true because 4 is equal to 4. So the number inequalities people don't usually have trouble with, but once we stick variables in there, then people start to get confused. So if I have something that says x is less than 4, that means x can represent any number less than 4. So it could be 3.9, it could be 3.9 repeating, it could be 2, it could be 0, it could be -5, it could be -6, it could be -2016. And we could be here all day listing those numbers. So what we do instead, because of the fact that that would take too long and that's just not worth our time, what we do is we use a number line to represent x is less than 4. So what we do is we make a number line. Your number line does not have to start at 0. I just like to put the number that I need in the middle, and I put one below and one above. Try to make it evenly spaced, but there's no judgment here as to your drawing ability. So if x is less than 4, all those numbers that I listed would be on this side of 4 because it's less than. Because this, if x is 3, that's less than 4, 2, 0, they're all on this side of 4. So that means that side gets highlighted, if you will, and then I make the arrow nice and big to show that it goes on forever. Now here's the tricky part, because I need a dot on the 4, because that is, it's called the boundary point, or sometimes it's even called the dividing point, because it divides your number line into two parts. So it's either called the boundary point or the dividing point. Now, notice how that circle is open, it is not filled in, and that's because it's not equal. So when it's not equal, you need an open dot, because it's kind of saying like that is my fence or that is the edge, but I can't actually sit on that 4. It's kind of like I'm highlighting up into it and I'm exaggerating that point, but I can't sit on it. So x is less than 4 is going to look like this with an open dot. Okay, so let's take a look at these two examples. I have x is less than or equal to 2. So since it can be equal, I need a solid dot. So I'm going to put a solid dot on my 2. And the numbers that are less than 2 are to the left of 2, so I'm going to highlight to the left and highlight the arrow. For x is greater than -6, be careful when you do the number lines with negatives, because one up from -6 is actually -5, and one down from -6 is -7, so be careful not to get it backwards. Now this is greater than, and this is not equal, so this is going to be an open dot. So I have an open dot on my -6, and then all the numbers greater than -6 are to the right. So it looks like that. When you have a problem like this, where you have x plus 4 is less than or equal to 9, first off, you're going to pretend it's equals, and you've got to find out what number is going to make that equals, because that is your dividing point. So now I know that I need the number that makes it equal. And in this case, it's going to be 5 because 5 plus 4 is equal to 9. So I know that my boundary point is 5 because that separates numbers that work and numbers that don't. And since 5 plus 4 is equal to 9, and there's the equal thing here, I'm going to make that a solid dot. So now the question is which side to shade. So which numbers work, the ones down here or the ones up here? Now I have less than or equal to 5 here because I just copied this symbol. But you can always test it in the equation. So if I take this 4 and put it up here and say 4 plus 4, that's 8, and 8 is less than 9, and that's true. So since that's true, that is the side that gets shaded. Similarly, if I were to take the 6 and plug it in, I would get 6 plus 4 is 10, and 10 is less than 9 is false, so that's why this side does not get shaded. So the side that gets shaded makes it true. So if I were to ask you to solve and graph this inequality, 2x plus 3 is greater than 15. Since I want to find the number that makes it equal, you can just kind of pretend, okay, if this was 2x plus 3 equals 15. Well, 15 minus 3 is 12, and I know that 2 times 6 is 12, so now I know that my boundary point is 6. Now I'm going to take this symbol and say x is greater than 6. Since my x is on this side, that's perfectly okay to do. So this is my solution right here. Make sure that you write your solution. Don't just write the 6. That's not enough. I'm going to put my number line down here, 6, 5, and 7. Since this is not equal, I want to open dot on my 6. So now I'm going to test each side. So if I use the 5 and put it up here, I would have 2 times 5 is 10, plus 3 is 13. 13 is not greater than 15. So I'm thinking I need to shade the side over here with the 7. But let me test it. 2 times 7 is 14, plus 3 is 17. 17 is greater than 15. So yes, that works. So that is the side I'm going to shade, and that graph matches my solution of x is greater than 6. So I have solved it and I have graphed it. That is how you solve and graph inequalities.